Hi everybody, welcome to Mitch Maths. My name is Mitch, and in this video we're going to be looking at sets. So a set is essentially a collection of things. So in maths that will be a collection of numbers. And in this video we're going to be looking at set notation, so all the symbols that make up sets and what they mean. We're then going to be looking at how we can describe sets using symbols and numbers and even words. We're then going to be looking at the union and intersection of sets. We'll be looking at the complement and then subsets, and I'll be showing you guys some examples of all of this stuff as well. Okay, so let's go over some set notation then. So here I have a set, and the reason why we know it's a set is because we have some curly brackets here. And this tells us that it's a set, and whatever is written inside the curly brackets is what makes up our set. So in this example, the numbers 2, 6, 10 and 18 all make up our set, okay? And we can give our sets names as well. So these are usually given capital letters as names. So in this case, we've called ours M. So our set M is made up of the numbers 2, 6, 10 and 18, okay? But we can also have words that make up our set as well, or help tell us what is in our set. So if we had another set, let's call it N. In this one, we could have, say, all the even numbers. In this case, we can write even numbers, and that can be our set, okay? So all the even numbers is what makes up our set N, okay? The next symbol you guys need to know is this one, okay? And it kind of looks like the euro symbol, but not quite. And this stands for a member of, okay? So the way you'd use this one is if we could write something like 6 is a member of M, okay? And in our example, in our set that we called M, 6 is a member, okay? So we could write 6 is a member of M using this symbol right here. And equally, we could also use this symbol to show what is not a member. So we could use the same symbol, but this time we're going to put a line through it, okay, to say is not a member. So this time we could choose something like 7 is not a member of N. Okay, and remember N is our set of even numbers, and 7 is obviously not an even number. So 7 is not a member of N. And here I have some really important sets that have their own notation, so let's go over those as well. The first one is what we call the empty set, okay? So this is a set with nothing in it, and the way we denote that is with some curly brackets again, but this time there's nothing inside them. It's just nothing inside them, two curly brackets together. Or we can also use the symbol of a circle with a line through it like this to show that it's an empty set. So an example of that then would be something like if we had our set which we'd called B, and we said that inside B it has all of the negative numbers between 10 and 20. Okay, obviously there are no numbers between 10 and 20 that are negative, so we can say B is equal to that symbol. Could have chosen either one, but I chose the circle with the line through it. So B is equal to the empty set because there's nothing in it. Okay, the other one I want to go over is the universal set. So this one is really, really important because the universal set is basically our starting set. And the symbol we get for this is called xi, okay? The Greek letter like this, quite difficult to draw, but it's kind of like a capital E with a few extra squiggles. And this is essentially our starting set from where all the other sets that we're working with come from, okay? So all the numbers from our following sets must be in the universal set. And this will become really, really clear in some of the later examples that I have in this video. Okay, so now I've got an example here of how else we can describe sets. So I've got an example, and so we have, first of all, two sets, and here we have our universal set, okay? Just been over what that is. So our universal set is our pool of numbers, if you like, which all the other sets can take their numbers from. So in this case, the universal set is the positive integers, okay? So it's all the positive whole numbers that we have. So, and then we have our set E. And here we have a new symbol which we haven't seen yet, and it's this colon. And the way you'd read this is, so E is a set of numbers, which we call X, such that, okay, this colon means such that X is less or equal to 4. Okay, so X stands for any number such that those numbers are less than or equal to 4. Okay, so, and this question asks us to list all the members of E, so all the numbers that X can be, right? So the way we do this then is we look at numbers which satisfy both of these sets, numbers that satisfy the rule that we have in E, but also belong to our universal set. Okay, so here we're looking for numbers which are below or equal to 4, and this one we're only looking for the positive integers. So that means that the only numbers that are positive and below or equal to 4 are 1, 2, 3, and 4. Okay, and that's it. And they are the only members of E, because any number below this will not satisfy it and will not be in our universal set. Any numbers higher than this will not satisfy our rule that we have in E. So another way we could have written E here is if we used set notation, we could have this curly brackets, and we could have 1, 2, 3, and 4 in the curly brackets, just like that. Okay, but that's the answer to that question. Only numbers that are from our universal set, and only numbers that satisfy the rule that we've laid out here, which is E equals X such that X is less than or equal to 4. So X must be less than or equal to 4, and this is our answer. Okay, so let's go over some more attributes then that our sets can have. So here we're going to talk about the union, intersection, and then number of as well. So the union. So the union of two sets is denoted by essentially a U symbol. So if we have a set A and a set B, with this symbol in the middle, this means we're looking for the union of sets A and B. And what that means is we want all the members from both sets. Okay? So we want all from both. So this is every member from set A and every member from set B, okay, all together. If we're looking for the intersection, okay, the way we denote this is a symbol just like the union one, but upside down. Okay, so like an upside down U or like an N shape, upside down semicircle. This is the intersection between A and B. And this one is only the members that appear in both. Okay? So only if in both sets. Okay? So these are really, really similar symbols. So one is just one semicircle, one up, one way up, and the other one is just the same thing the other way around. And the best way, I think, to remember these, because you don't want to get these mixed up, is the one that looks like a U is for the union, and the one that looks like an N is for the intersection. Okay, so we've got a U for the union, and if I grab another pen, we've got the N for the intersection. Okay, and that's how we can remember which way around these things go. So the last one we're going to cover in this bit is looking at the number of. So this is simply just looking at the number of members in set A. Okay, so we're looking for the number of members in the set. Okay, so top one we've got the union, which is all of the members from both sets, the intersection, which is only the members that are in both sets, and the bottom one, the number of, which is just the number of members in the set. Okay, now let's go over an example of where we can use these and show you exactly how they work in practice. Okay, so let's look at this example here then. So first things first, we've got our universal set. So remember, all the following sets must take their numbers from this set. And in R1, we've got 1, 3, 5, 6, 12, 14, 18, 34, and 36. We've then got two more sets here. So we've got set C, which is the odd numbers, and we've got set F, which is the multiples of 3. And first things we want to look at is the union. Remember, our symbol in the middle looks like a U, so therefore it's the union. And if you remember, the union is all of the numbers that can be in either one of our sets. Okay, so the best thing to do with this then is to go through our universal set, because there aren't that many numbers in it, and let's look at each one individually and look at if it can go into either one of our sets, C and F. Okay, so let's do that then. So our set C is for odd numbers. So straight away we know that all the odd numbers in this set are included. So the first three, 1, 3 and 5 are all odd numbers, so they're in straight away. Okay, and then any other odd numbers here? No, we don't. So now we just have to look through which ones are multiples of 3, so therefore they'll be members of F, and they'll be also included in our union. Okay, so we have 1, 3 and 5, they're in. 6, yep, that's a multiple of 3, so 6 is in. 12 is also a multiple of 3. 14 is not a multiple of 3. 18, yep, 3 times 6 is 18, so 18 is in. 34 is not a multiple of 3. And 36 is a multiple of 3. 12 times 3 is 36. And there we go. Those are all the members that make up the union of C and F. Okay, all the numbers that can be in either one of our sets. Moving on to the intersection then, and we notice the intersection because the symbol in the middle kind of looks like an N, it's for intersection. So now we want just the numbers, or just the members from the universal set that go into both of our sets, both sets C and F. Okay, so again, let's go through our universal set then and look at which ones go into both. So first of all, we have 1. It is an odd number, but it's not a multiple of 3. 3. It is an odd number, and it's a multiple of 3. Okay, so 3 is in. 5. It is an odd number, but not a multiple of 3. And then for all of the remaining numbers, we know by looking at them that they are not, none of them are odd. Okay, so that means none of them can be in our set C, which means that none of them can be in the intersection of C and F. So therefore we can just stop right there, because we know that the only number that satisfies both and will be in both sets is 3. Okay, so now looking at the last couple of bits then, so now we will look at how many members are in set C. Okay, so C is looking at just the odd numbers of our universal set, and we know the only odd numbers are at the start, so 1, 3 and 5, so therefore that's 3 for 1, 3 and 5. Okay, and the same thing then with our set F. We want to look at how many members there are of our set F. So here we want to look at all the multiples of 3 in our universal set. So we've got 1 here for 3, we've got 6 and 12, we've also got 18 and 36, all in the 3 times table. So that's 1, 2, 3, 4, 5. So that means the number of members in set F is 5. Okay, I hope that made sense. I hope that gave you a good demonstration of what the union, the intersection, and the number of members symbols are, and how you can work them out with a good example here. I hope that helps. Okay, so now let's look at the complement. So a complement of a set is all of the numbers that are not in that set. Okay, so in this example here then, so we've got our universal set here, and here we have our set P, which is all the even numbers. So our complement of P, okay, which is usually denoted by the same letter but with a dash above it, okay? So I know this is prime, so this would be P prime, okay, P with a little dash. And so this represents the complement of P. So in this example, the complement of this is all the numbers that are not in this set. So this is all the even numbers. So the opposite of even is odd, so that means that the complement will be all the odd numbers. So it'll be all the odd numbers of this universal set. So in this example then, let's go through and pick out all the odd numbers. So we've got -1, okay, and we've got 41. So those are all the odd numbers, okay, and that is what makes up our complement of P. A good way to check this as well is if we were to work out what P was and find out all the members of P. So it's all the even ones. So that would be minus 8, minus 6, 16, and 142. We could just do this, find out what P is, and then just pick out all the numbers that are not these, basically. So the only numbers left in the universal set are the minus 1 and the 41. Okay, and that is the complement. I hope that wasn't too difficult. It's basically just all the members of the universal set that are not in the set that we're looking at. So the last new concept that we're going to look at in this video then is subsets. So a subset is a set that can fit entirely within another set, okay? So all of the members of that set are in another set. So the example I've got right here then is, so we've got x, 2, 6 and 10, and y, just even numbers. So x, all of the members of x are also in y, because y is even numbers and all of these are even numbers. So therefore we say that x is a subset of y, okay? And the way we denote this is with this symbol here, which is really similar to the is a member of symbol, just without that little bit in the middle. So the way we'd write this then is we'd write x is a subset of y, like this. So that's what that says, okay? Equally, if we were to have another set, so say we've got set z, and this had the numbers, say 1, 2 and 6 in it. There's now an odd number in here, 1, so therefore z is not a subset of y, and we can write this like this. So the same symbol, but again with a line through it to show that it's not the case. So this is now saying that z is not a subset of y. Okay, so I hope that makes sense. Is as long as all of the members of that set are within another set, then it's the subset. Okay, so now I'm going to go over just one more example then, slightly more tricky example, just grouping a few of these concepts together then, and hopefully after that this will all be clear and you'll be an expert on sets. Okay, so here's our last example then that groups together a few of the concepts that we've just been talking about. So we've got our universal set. So this is the positive integers that are less than 20. We've now got our set A, which is of x such that x is greater than or equal to 8 and less than or equal to 14. We've then got our set B, which is the multiples of 4. And then we've got our set K, which is the odd numbers. Okay, and the question is the complement of the union of A and B a subset of K? So is that true? Okay, so that's what we need to work out. So there's a few elements to this. So the way we tackle this then is just to go through it like it was any other equation and go through it step by step. So the first step then is inside the brackets, we've got the union of A and B. So the first step we want to work out then is the union of A and B. So remember, the union is any number that is in either set of A and B. So let's go through that then. So we want to have the multiples of 4 and x such that x is basically between 8 and 14 inclusive. So the multiples of 4 then, so we've got 4. So don't forget, positive integers less than 20, so the number's 1 to 19 essentially. So multiples of 4, we've got 4, 8, 12 and 16. Okay, not 20 because it's numbers less than 20. Okay, so those are all the members that make up multiples of 4, our set B. And our set A is just all the numbers between 8 and 14 inclusive. So we've got 8 already, so we've got 9, 10, 11, we've got 12 already, 13 and 14. Okay, that is the union of A and B. But we want the complement of this. So this is all the numbers that make up our universal set at the top, which do not appear in the union of A and B. So the complement of this is all the numbers that are remaining. Okay, so we're going to have 1, 2, and 3. We've got 4, so it'll be 5, 6, 7, 8 is here, 9, 10, 11, 12, 13 and 14 are all in this part, so they're not included in the complement. So what's left, we've got 15, 16 is in this one already, 17, 18 and 19. Okay, so that is the complement of the union of A and B. This is all the numbers that were not included in the union. So now the question is this a subset of K? Okay, so if you remember, K is all the odd numbers. Okay, so therefore are all of these numbers odd, and therefore there'll be a subset of K. So if we look at this, they're not, are they? Because we've got 2, we've got 6, we've got 18, and they are even numbers. So therefore, the complement of the union of A and B is not a subset of K. So therefore, this is false. Okay, so there we go, just showing that's false. I like this example because it shows you a good example of how we've used the union, the complement, and subsets. I hope that made sense, guys. If it didn't make sense, then I recommend going and checking out some of the earlier parts of this video. And then if you keep watching those, keep practicing, and then hopefully this kind of thing will just become second nature. If you like this video, then go check out more videos by Mitch Maths. And thank you very much for watching, and stick around for my next video on Venn diagrams, because that follows on really nicely from what we've done in this video on sets. Okay, thank you very much for watching.